Okay, in this session we're looking at inverse variation. So inverse variation, things about inverse variation is that increasing one variable causes a decrease in the other. Second thing is if the product of the two variables is a constant, third thing is that neither variable is 0, and the other thing is that when you graph them you get something that looks like that. So the graph is a hyperbola. Alright, so they're the main things. Now, of course, with this last thing here, with your graph being a hyperbola, so if we graph, say, y against x, and we get a graph like so, if we change that and graphed y against 1 on x, what we then would get would be a straight line. So from this we can conclude that for inverse variation, y would be proportional to 1 on x, and so y equals k over x would be a general form of inverse variation. Okay, and there's lots of examples of this sort of thing. Okay, so let's have a look at an example. So the example we've got, we've got to determine whether there's determining whether direct variation exists and finding the equation in the following table. So here's our table here. So we've got x values of 1, 2, 3, 4 and 5, and our y values are 20, 10, 6 and 2/3, 5 and 4. So if direct variation exists, y would be k over x, and if we multiply both sides by x, xy would be equal to k. So we add another line down under here, which is xy, and then we multiply these things together. 1 times 20, of course, is 20, 2 times 10 is 20, 4 5s are 20, so 5 4s are 20, and 3 times 2/3, well, 3 6s are 18, and 2/3 times 3 is 2, so that's 20 as well. So we have, therefore, direct variation, seeing as this product here is the same in each case. So that means our equation then would be y equals 20 over x. We could, of course, do that graphically by, graphing y and x and then having a look and using our calculator. And if you want to know that, look in your textbook, page 237. There's something in your textbook about that. Okay, so let's look at a second example. Okay, so this time we're told that we have inverse variation, that y is proportional to 1 on x. So we want to find the constant and the missing values. So the constant, let's put the thing, so we've got x and y. And in this table, we've got the following things that are given to us. Let's get rid of that, it shouldn't be there. The following things that are given to us. Alright, so there they are. So we've got some y values and some x values that have been given to us. So we know, because we were told y is proportional to 1 on x, so we know then from that y equals k on x, and the last two there, 6k4, so k would be 24. So if k is 24, we've now got y equals 24 on x as our equation. And we can then use that to help us. So in the first one, you got 24 equals 24 over x. Okay, so from what we know there, x, to get 24 from 24, the only thing you can divide it by is 1. There for that one. The next one we're looking at is y equals 24 over 2. Of course, that's got to be 12. One after that is 8 equals 24 over x. So what goes into 24 8 times? I think we'll find out 3. Alright, so just a bit of deduction on those ones. Alright, so let's look at another example. Okay, so what we're going to do is look at example 10 on page 239 of your textbook. So when we look at that, Marina's buying prizes for competitions which are held during Maths Week. She has enough money to buy 24 pens at $2.50 each. Okay, so pens of better quality are sold at $4 each. How many of these can she buy? If she wishes to buy enough identical prizes for 100 students, what would be the maximum cost? Okay, so let's have a look at our thing that we have. So 24 prizes. For 250 cents, $2.50 times 24 equals $60. So she's got $60 to spend. Now, this is all kind of all a bit, deduction and not mathematical, in the sense of what we're doing, coming up with an equation and all that sort of thing. Because if you say pens of better quality are $4 each, and whoops, not $64 we don't have, but we have $60, and divide that by $4, and therefore she could get 15. Not really over mathematical in the sense of what we're doing, setting up equations here. So if we let n equal say the number of prizes, that we're going to put out, and we let p equal the cost of each prize, and then we can set up some sort of equation. So the number of prizes, obviously this one's going to be inverse variation is going to be k, whatever k is, over p, the cost of each prize. Okay, because obviously we've got a fixed amount of money that we've got to spend. The more the prizes cost, the less of them we can get, and vice versa. So that's the inverse variation. So if we have a look at that, and then we go, okay, so in using our first lot of information that we were given, that we read, and that was our 24 prizes that cost $2.50 each. So if we have 24 prizes at the cost of $2.50 each, we come out then that k is 60 again. Okay, so setting up the equation, let's have a look. That then, so the number of prizes then would be 60 over the cost of those prizes. So in part A then, part A is saying that now the cost of the prizes is now $4. How many can we get? Well, 60 over 4, and we can get 15 prizes. So 15 students would get a prize. Okay, part B says if she wishes to buy enough identical prizes for 100 students, so the number of prizes has got to be 100. What's going to be the cost? So if n equals 60 over p, the cost of the prize, so 100 equals 60 over p, the cost of the prize, and then when we do a bit of rearrangement, hopefully we'll find out that the prizes then for that particular one would be 60%. Alright, kind of that's about it, although I will emphasise something that I hadn't before. So inverse variation, y is proportional to 1 on x. Okay, as one decreases, the other. So in this one, as x goes up, y will go down, and vice versa, of course. Now, because when we put the k in, y equals k on x, there's a couple of restrictions that I didn't emphasise that I probably should have. First of all, k, it's got to be a real number, excluding 0. Because if k is 0, you just got y equals 0 and it makes no sense. The other restriction, of course, is on x, and x, of course, can be an element of R, but it can't be 0, because if x is 0, the thing would be undefined. Alright, so that's it, exercise 7C, which is set number 3 in your textbook. You can get going and working on that one.